Hello students, the next topic in this unit is radius of curvature. Now here in this question they are asking us to find the radius of curvature of the curve x power 4 plus y power 4 equal to 2 at the point 1, 1. Now here the given equation, that is the given curve, is x power 4 plus y power 4 equal to 2. Now we have to find the radius of curvature for this curve at the point 1, 1. The formula for radius of curvature is given by rho equal to. So the representation for radius of curvature is rho. That is equal to 1 plus dy by dx the whole square, the whole to the power of 3 by 2 divided by d squared y by dx square. So this is the formula for radius of curvature. Now we know that in differentiation we have been representing dy by dx as y1. So dy by dx is y1 and d squared y by dx squared is represented as y2. And so this formula can also be written as rho equal to 1 plus, now we know that dy by dx is y1. So y1 square whole to the power of 3 by 2 divided by d squared y by dx square is y2. So we can represent it in this way also. Now moving on to the problem, first we will consider the equation that is given. So the equation given to us is, so it is given that x to the power of 4 plus y to the power of 4 is equal to 2. Now we have to differentiate this first to find dy by dx. So differentiating this equation with respect to x on both the sides. So what do we get now? Differentiation for x power 4 will be 4x cube plus the differentiation for y power 4 is 4y cube multiplied with the differentiation of y, because we are differentiating with respect to x and so we have to apply chain rule upon y. So 4y cube multiplied with dy by dx is equal to, on the right we have a constant 2. The differentiation of a constant is always 0. So it will become 0 here. Now from this we can find dy by dx. That is, from this we get 4y cube dy by dx to be equal to, that is we are having this on the left side and we are taking this term to the right of the equation. So when this term moves to the right of the equation, it will become negative and then 4x cube. Now from this we can obtain dy by dx. So what will be our dy by dx from this? It will be equal to minus 4x cube divided by 4y cube. So now 4 and 4 gets cancelled and so therefore our dy by dx is equal to x cube minus, we have this negative sign, so minus x cube divided by y cube. So this is our dy by dx. Now here in the question we can see that they are asking us to find it at the point 1, 1. Actually we have to find the radius of curvature by using this formula. Now for this we need dy by dx and d square y by dx, so that we can substitute those two in this formula. But what they are asking is, they are asking us to find at the point 1, 1. So radius of curvature at the point 1, 1 we have to find. That is, at the place of x we have to replace by 1 and at the place of y we have to replace by 1, because this is the x coordinate and this is the y coordinate. So now when we do so, we should also find dy by dx at the place of 1, 1 and d squared y by dx squared at the place of 1, 1 only. So now if you see here, dy by dx we have evaluated. So now we have to find dy by dx at the place of 1. So dy by dx at the place of 1, 1. So at this coordinate will be equal to minus. So at the place of x we have to replace it by 1. So it is 1 cube, so it will be 1 only, divided by, at the place of y we have to replace by 1. So 1 cube is also equal to 1 only. So this will be equal to minus 1. So dy by dx at the point 1 comma 1 is minus 1. Now we have evaluated this. Now let us find d squared y by dx square. So that we have to find from this. So dy by dx we have got it to be minus x cube by y cube. Now we have to find d square y by dx square by differentiating this once again. So suppose if we mark this as equation 1, we could say that differentiating equation 1 again with respect to x. So what do we get? Now if you see here we have x cube by y cube, which we have to do by u by v method. So we know that the differentiation of u by v is equal to v squared, and then v multiplied with u dash minus u multiplied with v dash. We know this formula. So this is the rule. So now using this, now at the place of u we have x, and at the place of v we have y cube. So here x cube and y cube. So at the place of u we are having x cube, at the place of v we are having y cube. So when we apply the u by v rule method over this, what do we get? D square y by dx squared will be equal to, now this is our v. So we need v squared. So y cube the whole square, and then v multiplied with, so v is y cube multiplied with u dash. So u is what? X cube. So the differentiation for x cube is 3x square, and then we have a negative sign minus u multiplied with, so x cube multiplied with v dash. V is y cube, so differentiation of y cube is 3y square multiplied with dy by dx. And then we can see that we have a negative sign. No, that negative sign we can write in common outside. So this minus has come out, and the differentiation for x cube by y cube we have shown it here. But actually we have to find what? We have to find d squared y by dx square at the point 1 comma 1. So wherever we have say x and y, we will replace it by the value 1. So now if you see here, this will be minus of y cube. What is 1? Y is 1. So 1 cube will be 1 only, multiplied with 3x square. X is also 1. So 3 into 1, so it will be 3 only. So minus x cube. X is what? 1. So 1 multiplied with 3y square. So 3 multiplied with y is 1. So 1 square will be 1 only. And we have to write dy by dx. But what is dy by dx at the point 1 comma 1? It is minus 1. We have already evaluated here. So that we have to substitute. The whole divided by y cube is 1. 1 square is 1 only. So this is what we have to write. So remember very carefully, we are evaluating d square y by dx square at the point 1 comma 1, which means wherever we have x we have to replace by 1, and wherever we have y we have to replace by 1 in this. So while doing so, we see that we have a dy by dx. So dy by dx also we have already evaluated at the point 1 comma 1. The value is minus 1. So that only we have to substitute here. So these steps has to be carried out very carefully. So that is equal to, now minus into 3 1 times is 3 only, and then minus into minus is plus, and 3 multiplied with 1 is 3. The whole divided by 1, but anyway that is going to be 1 only. So minus, what is 3 plus 3? It is 6. So therefore d squared y by dx square at the point 1 comma 1 is equal to negative 6. So minus 6. That is what we have evaluated here. Okay, so that we have to substitute. Now we have got d square y by dx square at the point 1 comma 1, and we have got dy by dx also at the point 1 comma 1 to be minus 1. Now we have to take these two and substitute in our radius of curvature formula. That is over here and here. So after substituting, we will be able to find the radius of curvature, which we will see now. So now students, I have taken and written here dy by dx at the and d square y by dx square at the point 1 comma 1 is minus 6. Now the final step is we have to evaluate the radius of curvature. So what is the formula for radius of curvature? It is given by rho is equal to 1 plus dy by dx the whole squared, the whole power 3 by 2 divided by d squared y by dx square. Now at the point 1 comma 1 we have to evaluate. So here also at the point 1 comma 1 and this also at the point 1 comma 1. But we have already evaluated these two and we have it here. At the point 1 comma 1 we have evaluated this term and this term also I have written here. Now let us substitute these two values in this formula. So our radius of curvature will be equal to, so rho is equal to 1 plus, what is dy by dx at the point 1 comma 1? It is minus 1. So let us substitute that here. So minus 1 squared, the whole power 3 by 2 divided by d squared y by dx square at the point 1 comma 1 is minus 6. So we have to write that minus 6 here. So that is equal to 1 plus, what is minus 1 the whole squared? It is 1 power 3 by 2 divided by minus 6. And so this will be equal to 1 plus 1 is 2. So 2 to the power of 3 by 2 divided by minus 6. And so that is equal to, now this negative sign we will write in the front. Now 2 power 3 by 2 can actually be written as 2 cube the whole power 1 by 2 divided by 6. But what is this minus of 2? 1 power 1 by 2 is square root of. So it is square root of 2 cube, that is 2 multiplied with 2 multiplied with 2 divided by 6. So that's equal to, now these 2 times 2 is 4. So when it goes out of the square root, it will be 2. And this square 2 will be inside the square root. So 2 square root of 2 divided by 6. So therefore the radius of curvature rho is equal to minus 2 square root of 2 divided by 6. And this can be cancelled. And finally we get the answer to be negative square root of 2 divided by 3. The negative sign is negligible only, but still we can either give it in the answer or we can neglect it. It's not an issue. Therefore the radius of curvature rho is equal to minus square root of 2 by 3. Hope you have understood this problem. Thank you.